Hello friends, myself Animesh Sharkar. Welcome to our channel Electrical and Automation. Today we discuss our starter. Why use starter to run motor, type of starters, details of starter uses. Why use starter to run motor? Protections. Motor starter protect the motor from overload and short circuits. They typically include thermal overload relays that disconnect the motor if it drawn too much current, preventing overheating and potential damage. Control. They provide a way to control the motor start and stop function. This is often done with a combination of control contactors and switches, which manage the start commands. Safety. Standard starters ensure safe operation by providing a way to isolate the motor from the power supply, which is important for maintenance and troubleshooting. Soft starting. Some motor starters like soft starter VFD can gradually increase the voltage supply to the motor, which reduce mechanical stress and electrical inrush current. This can extend the lifespan of both motor and connected equipments. Compliance. The motor starters can help ensure compliance with the electrical codes and standards that mandate protective measure or electrical equipments. Type of starter. We have a many starting method to run the motors. Direct online starter, start delta starter, soft starter and VFD, variable frequency drive. Now we discuss our direct online starter. Direct online starter is a type of electrical starter used to start electric motor. It is one of the simple and most common method for starting induction motor. Features of stall. Simplicity. It is a straightforward and cost effective, making it its popular choice for small to medium size motors. Full voltage starting. The motor receives the full supply voltage during startup, which provide maximum torque but can also have a high inrush current. Protection include basic operation features such as overload protection, short circuit protection. Application typically used for motor up to 0.5 to 30 kW depending on the motor characteristics and the application. Common in applications like fans, pumps and compressor, where a high starting torque is required in this application. Advantages: simply designed and operation, low inertial cost compared to more complex starters. Disadvantages: high inrush current during startup, which can cause electrical and mechanical stress on the motors and supply system. Dual starter connection diagram. When the start button is pressed, the contactor closed, allowing the current to flow directly to the motor. The motor starts accelerate is to full speed. Pressing stop button deactivate the contactors, cut off the power to the motor and stop it. Start delta method. Start delta method is a type of motor starter used to reduce the starting current of a three-phase induction motor. Reducing starting current. When the motor is initially connects the star connection, it receives a lower voltage, which reduces the starting current to about one-third of current that would be drawn if the motors were started directly across the line. Low starting torque. The reduced voltage in the start connection also result in lower torque, which can be beneficial for application where high starting torque could cause damage or excessive mechanical stress. Transitional of full voltage. After the motor reaches acceleration speed, the starter switches the connection from start or delta, allowing the motor to operate at full voltage and develop full torque. Application. Start delta starters are commonly used in applications where the motor needs to start with the reduced current and torque, such as in large pumps, fans and compressor. Advantages: starting current, reduced mechanical stress, energy efficiency. Disadvantages: complexity, not suitable for all loads. Next we discussed Start delta connection diagram. Connect the three-phase supply, the input terminal of the MCB. When the start button press, the starter contactor close, connecting the motor winding start configuration. The motor starts with a reduced voltage or lower set starting current. The timer is also activated. The timer monitors the motor startup phase. After preset timing, example for 10 seconds, it triggers the switching of the start to delta. The starter commands delta contactors close, changing the motor winding to the delta configuration. In delta configuration, the motor receives full line voltage providing full load torque. Efficiency: when the stop button is pressed, both main and delta contactor open, disconnect the motor from the supply and stopping it. Soft starter. It is a device used to control a starting and stopping of electrical motors, provide a smooth and gradually acceleration and deceleration. Features of soft starter: voltage ramp controller, provide a small start and stop, reducing mechanical stress and electrical ingress currents. Current limits: control the amount of current drawn by the motor during startup. Adjustable start and stop profiles, overload protection also there, phase loss detection also there. Applications: we have used in pumps and fans, blowers, compressors, conveyors, elevators and lifts. Advantages: reduced inrush current, reduced mechanical stress, extended motor life, protection features. Disadvantage: initial cost, heat dissipation, potential for increased complexity in fault diagnosis. VFD is an electronic device we use to control the speed and torque of an electric motor by varying the frequency, voltage and supply to the motor. Speed control: allow precise control of motor speed by adjusting the frequency of power supply. Torque control: ensure the motor can provide the necessary torque for various applications, preventing overloading and impairing performance. Motor protection: maintenance the motor and monitor the motor current and temperature to prevent overheating and damage overloads. Ensure energy efficiency: reduce energy consumption by adjusting the motor speed to match the load requirements. Application: we have used pumps, application fans and blower, compressor, conveyor, elevators and lifts. Mixer and agitator also we have used in VFD. Advantages of VFD: energy savings, improved process control, reduce mechanical stress, enhance safety features. Disadvantage of VFD: initial cost, heat dissipations and harmonics. VFD can introduce harmonic distortion into the power supply, which may affect in the electrical equipments, reduce power quality. Thanks for watching my videos. Please like, share and comments.